Hey everyone, I am Miss Hu, your physics teacher. In this video, I will be discussing the answers to a past year question and then we will compare the answers to the mark scheme. For some questions, the answers will be covered first so that I can explain the thought process of getting to the answers, as you will need to know how to get the answers and not just what the answers are. Then, based on the mark scheme, I'll explain why the marks are awarded as such. Question 2. A. A resultant force is applied to an object moving with a velocity v in a straight line. State 2 different changes to the motion that the resultant force may cause. Now, for this question, you need to know what the effects a force has on an object. For this particular question, you need to specify the changes made to the motion. Now remember that motion refers to the movement of an object. So imagine now this object is moving with velocity in a straight line and there's a force applied to the object. Now think, what effect could the force have on that object? So for one, of course, the force could be made to change the direction of the object. So that is what you can write. Change in direction. Now that's if you apply a force at a different angle. A force could also be moving the same direction. That means the object could be moving this way and there's a force in the same direction, or the force in the opposite direction. The changes that could be made to the motion would be, for one, to change the speed of the object. So it could make the object go faster or could slow the object down. So that's what we could also write. Now, if there's a change in speed, it's also possible to change the velocity, because remember that the difference between speed and velocity is that speed is scalar and velocity is a vector. So speed does not take into account direction while velocity does. A change in speed would definitely mean that velocity could change because the magnitude of the velocity has changed. So I'm going to write here magnitude of velocity. Another way to express this is to talk about the acceleration, because if the speed changes, meaning it increases in speed or decreases in speed, or increases in velocity or decreases in velocity, that means there is acceleration or deceleration. Now, whether it's accelerating or decelerating depends on the direction of force relative to the object's movement. In this case, we can just put acceleration in general, because deceleration is quite simply negative acceleration. Now let's take a look at the answer. So as you can see in the answer scheme, 1 mark is awarded for stating the change in direction, and another mark is awarded for any one of the following: stating the change in magnitude of the velocity, or the speed, or that there is acceleration. Now notice that all of this is grouped under 1 mark, which means that if you were to write any of these across 2 points, you're still going to get 1 mark only. Now, the reason for this is because they're all related, as I had explained earlier. A change in speed could mean the change in the magnitude of velocity, and a change in either one means there is acceleration. So because they're all very much related and are kind of about the same thing, that's why these are all accepted only as 1 point. You have to talk about 2 different kinds of effects of the motion. So that's why you find direction is all on its own, because it's different from the change in speed, velocity, or acceleration. So that's why the marks are awarded as such. Now let's look at question A2. State one other way that forces may change a stationary object. So this question is actually asking for one other way that may change a stationary object. So this is still about the effects of a force, but you cannot talk about how the force affects the motion, because that was already asked in A1. A2 is asking for something else completely different from the effects on motion. And we're considering the stationary object this time. So you cannot say, oh, it will make the object move. That will be changing the motion. So try to recall, what other effects of forces have you learned? Yes, you have learned about how the forces can change the shape and size of the object. For example, if you have a spring, if you extend it, you change the size. Or if you were to apply a force on, say, a piece of modeling clay, you'll change the shape. So that's why the answer to this question is either one. You can say the change in size, or you can say the change in shape. You can just choose either one. You do not have to write both. So as you can see from the answer scheme, either one will give you 1 mark. B. Describe how a uniform meter rule, a pivot, and a selection of masses can be used to demonstrate that there is no resultant moment on an object in equilibrium. You may include a labeled diagram in your answer. So this question is kind of like asking you for a very simple experimental procedure where they've given you the list of apparatus and materials. When they say you may include a labeled diagram, that means the diagram is optional. You're not required to draw the diagram. So even if you don't draw a diagram, it's still possible for you to get the full 4 marks. Normally, we'll draw a labeled diagram if, let's say, we find it difficult to explain the setup in words. So where would the 4 marks come from? Because I've given you the apparatus and given you a suggestion of a diagram here, 1 mark will definitely be given for the setup. So if you're not sure how to describe the setup in words, then you can draw the diagram out. Let me give you an example of what kind of diagram you could draw. First of all, you need to know what the experiment should look like. You have a uniform meter rule and a pivot, and this is going to be a study on resultant moment. So you need to balance the meter rule on the pivot, and the purpose of these masses is to get the meter ruler to balance on the pivot, because we want to demonstrate that there is no resultant moment on an object in equilibrium. So an example of a setup that you could do would be to draw the uniform meter rule on a pivot. Now when you draw this, you should draw this in pencil and use a ruler to make sure that you've got straight lines. This particular app I'm using doesn't have the option of straight lines, so I'm going to try to draw as straight as possible, but you better use a ruler. So we have a uniform meter rule, which we will balance on a pivot. Now, my recommendation is to place the meter rule on a pivot at the center of this meter rule. Why? Because the center of a uniform meter rule is where the weight acts from. So if the pivot is directly under the center of gravity or center of mass, then the weight of the meter rule will not cause any moment around the pivot, and that makes it easier for any calculations. Now, to demonstrate that there's no resultant moment, you can place a mass on either side of the meter rule. The distance of the mass from the pivot will of course depend on the weight of each mass. So I've just drawn them to be different sizes just to help visualize that they could potentially be different weights. Now, the diagram must be labeled as mentioned here in the question, because you cannot just assume that the examiner will know what all these blobs are. For example, if you look at this now, probably have to try to guess what all these rectangles are. So by labeling them, it makes it a lot clearer what we're looking at. So I'm going to label here, this is the uniform meter rule. I'm following the name of the apparatus as written in the question. This is the pivot. And you can just label these as masses, just to show that that's what those blocks are. Now, if you don't want to draw, you can also describe this in words instead. So to describe the setup, I'm going to write here, place the meter ruler on the pivot where the pivot is under the center of the meter ruler, or words to that effect. So once you've described the setup, you need to explain next what you're going to be doing to demonstrate the result that we want. So what are we going to do with the masses? We're going to place a mass on either side of the pivot until we get a situation where the meter ruler is balanced on the pivot. For this, you do not need to give any suggestion of the values of the masses, because you're describing this activity in general. So you can think of this as a simple set of instructions that you're going to be giving to someone to conduct in order to do this particular demonstration. If you specify the masses, for example, if you say, oh, use a 1 Newton mass and a 3 Newton mass and place it at this distance, the problem is, what if that particular setup does not have a 1 Newton and 3 Newton mass? And suddenly like, oh, we can't follow these instructions after all. The thing is, they still can if they use their own values of masses. So in this case, don't suggest a particular number. Just explain in general how this particular activity could be done. So we could say, place a mass on one side of the pivot and place another mass on the other side of the pivot. And we're going to adjust the position until the meter ruler is balanced. It's going to adjust this so that we can see the words. So once it's balanced, we have now demonstrated that there is no resultant moment on an object in equilibrium. But here's the thing, this is a 4-mark question, and actually this is only worth 2 marks. So where do the other 2 marks come from? This is a physics question, so this means that we need to demonstrate our understanding of the physics concept. In this case, the physics concept we need to explain is moment. So what is moment? Moment is the product of force and its perpendicular distance from the pivot. So now that we've explained moment, next we should explain what it means by the object being in equilibrium with no resultant moment. Now, if we place a masses on the object, will there be moments about the pivot? Yes, there will be. The only thing is that there's no resultant moment because the moment in both rotational directions are cancelling each other out, meaning that all the anti-clockwise moments are balanced by all the clockwise moments. So that's another thing that you can use to explain this object in equilibrium. So you can explain when the meter ruler is balanced, or you can say in equilibrium. So don't just write anti-clockwise moment equals to clockwise moment, because what if there were more than one? So we'll say the sum of the anti-clockwise moments is equal to the sum of clockwise moments. So now let's check the mark scheme. So you can see from the mark scheme, the first point is awarded for the setup. So I'm going to label that here. So it's either or. You either describe that you place a meter rule on a pivot, or you draw the diagram showing the meter rule on a pivot. So 1 mark is given to either one because that's for the setup. So this is number 1, by the way. That's a setup. The second mark, as you can see, is awarded for describing how the activity should be done. We add mass on one side and then add mass on the other side to balance the ruler. Or words to that effect. So even if you're using slightly different words but describing the same thing, you can still get marks. So 1 mark is given for describing the procedure of the activity that needs to be conducted. The third mark is awarded for the equation of moment. So as long as you give the equation or the definition, you can get the third mark. The final mark is explaining how the moments balance each other when in equilibrium. So the sum of clockwise moments equals to the sum of anti-clockwise moments. So this is the condition for equilibrium. So that's, whoops, let me just write number 1 here. And that's how you can figure out the 4 points you need to get in order to answer this question. And that's question 2. If you found this video to be helpful, click like and subscribe. And do let me know how you have found this video to have helped you. To watch videos on other questions, check out the playlist on my YouTube channel or on my website, physicsrocks.com, to find the question that you are looking for. If you have any requests for a particular question, drop your request in the comments below, stating the year, month, variant, and question number. And if I haven't covered that question yet, I will do my best to come up with the explanation video as soon as possible. All the best for your examinations!